Hello everyone, this is the first of two videos about times table. In this video, we will look at how we can learn the times table from 1 to 10 without having to memorize most of it. As a private teacher in mathematics, I meet many students at different levels of knowledge in mathematics. Sometimes it happens that both students who go to primary and even secondary high school struggle with the times table, and thus with multiplication or division of numbers. The times table itself consists of 100 combinations where the numbers from 1 to 10 are multiplied by each other. The times table looks like this. Here we have, for example, 1 times 1 equal to 1, one combination. 1 times 2 equal to 2 will be another combination. 1 times 3 equal to 3 will be a third combination, and so on. As I said, we see here that in order to learn the times table, we must memorize all these 100 combinations. But not necessary. I will show you some tips and tricks that we can use so that the number of combinations we should learn is only 15 of them. In other words, from these 100 combinations, we will end up with only 15 of these that we should learn by heart, and the rest of the job will be to practice the simple techniques that I will show you. So let's get started. The first technique, which most people know and can already do, is that when we multiply number by 1, the answer or the product becomes the same number. Here we see that 1 times 1 is equal to 1, 1 times 5 is equal to 5, 1 times 9 is equal to 9, and so on. This means that we can remove or eliminate 10 combinations that we do not need to memorize. With this, we are left with 90 combinations that must be memorized. The second technique we are going to learn today is about how we multiply a number by 2. We can say that multiplying a number by 2 means that we sum the number by itself twice, or in other words, we double the number. For example, 2 times 3 it's 3 plus with itself twice, or the double of 3, which is 6. 2 times 5 is equal to 5 plus with itself twice, or the double of 5, which is 10. 2 times 8 is equal to 8 plus with itself twice, or the double of 8, which is 16. This means that we can take away 10 more combinations which we do not need to memorize. Thus we are left with 80 combinations. Now let's look at how we multiply a number by 10. We can say that a number multiplied by 10 is equal to the same number and added to a 0. By this I mean, for example, that 10 multiplied by 4 is equal to 0, 40. 10 times 7 is equal to 7, and then added to 0, 70. 10 times 9 is equal to 9, and then added 0, 90. And this applies to all integers. For example, 100 times 10 is equal to 100, and then added 0, 1000. 50 times 10 is equal to 50, and then added 1, 0, 500, and so on. So now we see that we have 70 combinations to memorize. The next technique is about how do we multiply numbers by 5. We can say that we multiply a number by 5 by multiplying that number first by 10 that we just learned, and then halving the result or product. For example, 5 times 4 is equal to 10 times 4 divided by 2, or the half of 40, which is equal to 20. Or 5 times 6 is equal to the half of 60, which is 30. Or 5 times 8 is equal to the half of 80, which is equal to 40. With that said, we are left with 60 combinations we have to memorize. Let's see how we multiply numbers by 9. We can say that we multiply a number by 9 by multiplying that number first by 10 and then subtracting the same number from the result or product. While this may sound strange, doing this in practice is easy. For example, 9 times 4 is equal to 40 minus 4, which is equal to 36, or 9 times 6 is equal to 60 minus 6, which is equal to 54, and 9 times 8 is equal to 80 minus 8, which is equal to 72. But why it is easier to subtract the number like this than to memorize the combinations themselves? Well, first of all, once you have practiced this technique for a while, you will get used to it, and it is much easier to remember a technique than to memorize 10 different numbers multiplied by 9, which you usually forget after a while unless you work with mathematics often. And secondly, it is not difficult to subtract, for example, 9 times 7, which is equal to 70 minus 7, because we know that the answer is smaller number, i.e. 60 and something. This something is a number that makes 10 with 7, i.e. 3. The first thing children learn in primary school in first grade after they learn numbers and counting are the pair of numbers that make sum 10, i.e. 0 and 10, 1 and 9, 2 and 8, 3 and 7, 4 and 6, 5 and 5, and vice versa. Therefore, for example, 9 times 4 is equal to 40 minus 4, which is equal to 30 and something, and that something is 6 because the sum of 6 and 4 are equal to 10. With this set, we have half the number of combinations that we have to memorize, from 100 to 50 combinations. The last technique that we are going to learn, and that will help us to further halve these 50 combinations to 25, is that when we multiply two or more numbers, the order of the numbers does not matter, i.e. the result is the same. For example, 2 times 3 is just the same as 3 times 2, which is equal to 6. Or 5 times 6 is just the same as 6 times 5, which is equal to 30. In professional mathematical language, we say that multiplication is commutative operation. This means that we can remove another 25 combinations, because when we learn, for example, 1 times 3, we learn at the same time 3 times 1, which is equal to 3. When we learn 2 times 3, at the same time we learned 3 times 2, which is equal to 6. When we learned 5 times 3, at the same time we learned 3 times 5, which is equal to 15. When we learned 9 times 3, at the same time we learned 3 times 9, which is equal to 27. And when we learned 10 times 3, at the same time we learned 3 times 10, which is equal to 30. And this applies also to the numbers multiplied by 4. And the numbers multiplied by 6. And the numbers multiplied by 7. And the numbers multiplied by 8. So that we are left with only 25 combinations that we need to memorize. But we can use the same technique, that the order doesn't matter when we multiply two numbers, to remove another 10 of these remaining 25 combinations. Because when we have memorized 3 times 4, we have at the same time memorized 4 times 3, which is equal to 12. When we have memorized 3 times 6, at the same time we memorized also 6 times 3, which is equal to 18. When we memorized 3 times 7, at the same time we also memorized 7 times 3, which is equal to 21. And 3 times 8 is just the same as 8 times 3, equal to 24. 4 times 6 is just the same as 6 times 4. 4 times 7 is just the same as 7 times 4. 4 times 8 is just the same as 8 times 4. 6 times 7 is just the same as 7 times 6. 6 times 8 is just the same as 8 times 6. And 7 times 8 is just the same as 8 times 7. Thus, we are left with only the 15 combinations with which we have started the video. And of this again, the easiest to memorize are so-called square numbers. 3 times 3 equal to 9, 4 times 4 equal to 16, 6 times 6 equal to 36, 7 times 7 equal to 49, and 8 times 8 equal to 64. We call these numbers complete squares. then it is best to memorize 3 times 4 equal to 12, 3 times 6 equal to 18, 3 times 7 equal to 21, 3 times 8 equal to 24. After that, we can memorize 4 times 6 equal to 24, 4 times 7 equal to 28, and 4 times 8 equal to 32. And then we are left with 6 times 7 equal to 42, 6 times 8 equal to 48, and in the end 7 times 8 equal to 56. So as I said in the beginning of the video, by memorizing these 15 combinations and by practicing the simple techniques I showed you, you will be able to learn the times table much faster and remember it forever. In the next video, I will teach you a simple method that you can use so that you can multiply the numbers between 11 and 20 with each other very easily. This means that once you understand the method, do not have to memorize anything from the timetable 11 to 20. Now we have just opened a door of the mathematical world. So welcome and enjoy the journey. Goodbye.